Evening, welcome to the stream, everyone. Let's do a really quick audio test. I think things are going all right. All right. Here we are again. So, still got this on the table, although that's not quite what we're going to be working on in the stream. I've got a mock-up, actually. So, yeah, this is a little bit of a diversion, but also not quite so much. I mentioned this a little bit on an earlier stream that I wanted to make just a nicer remote control for switching between different channels on the live stream. And right now my favorite solution is just a little matrix of buttons. So I found these cheap wireless numeric keypads that actually work all right. It's actually a pretty good solution, but this seemed like an opportunity to make something that fixed a couple of problems with the solution and also maybe gave me a project that hits a couple of pretty interesting notes. So I was thinking, well, one problem with this is I don't think the wireless is actually helping, because any of these wireless keypads tend to go into a low power mode when they haven't had any keys pressed in a while, and that means that inevitably I find myself in the situation where I'm doing something in the stream, and then I try to switch channels, and then this has to wake up, so I'm like pressing it a couple times, and there's about a delay of a second or so. So that's annoying. The Bluetooth one does something similar. It's also got a numlock, which is easy to press accidentally, and then it changes the meaning of everything else and makes it not really hotkeyable. It's not terrible, but it seems like I can improve it. And I also mentioned earlier that it would be nice to make something that's actually both flexible and magnetic, so I can stick it onto these lighting poles that I use to hold lights and cameras and other equipment around here. So ideally, my thing would be wired. It would have I keep imagining maybe a 3x5 grid of buttons that can just be programmed to be whatever I want. So ideally, I think I've been experimenting with hotkeys like Control-Shift-A or Alt-Shift-A, things like that. Control is actually bad because you don't want to hit Control-C or something. So yeah, like Alt-Shift-D or something, and you can usually just press one button. So, so the idea I had in mind for that actually, there's a couple of ways you can do this. There's a bunch of different ways to connect, buttons up to your computer. Oh, hey, Tuco. Cat's back down here. He was up here in his usual spot like 15 minutes before I started the stream, but I think he saw me milling about getting stuff set up and got a little more active. So there's a lot of different ways that you might... is Tuco going to hang out over here? Let's get this started while I'm here. Meow. Tuco, are you asking for something? Oh, Tuco wants to play. Well, maybe I can throw the bolt for my cat while I'm explaining this. For anyone who has not yet seen this, my cat is addicted to fetching these little nylon bolts. So... yeah. So basically my objective here is to have a pad of hotkeys that are wired, which is not a hard thing. There's a bunch of different options for that. Clearly I've been using a numeric keypad with reasonable success. And then, you can also imagine, modifying existing wireless or wired keyboards or joysticks and using software to remap them. We're using projects like the Makey Makey, using MIDI controllers. But ideally, I wanted something that I could interface with OBS without writing additional code or using additional tools, which meant pressing a hotkey that it knew how to capture, which is most things, but the the numeric keypad isn't really specific enough. Ideally, I would want something that includes modifiers or function keys or something. So the simplest solution with that constraint in mind seemed to be a microcontroller that had the ability to emulate a USB keyboard. And I first tried the Adafruit Trinket because I had a few of those handy, and they were a little smaller. And I was having some compatibility problems that seemed related to the way it implements full-speed USB in software on an ATtiny85. Come on, autofocus. This camera sure does have trouble with that light. So after having a little bit of trouble getting the Trinket to even communicate with all of the computers that I thought I might want to have to plug this into. How does that angle help? Then I went to kind of my old friend, the Teensy. And Teensies are really convenient as far as, a microcontroller that has Arduino IDE support for just a range of fairly handy basic USB device emulations. So it makes it pretty straightforward to emulate like a keyboard or a MIDI device. So I ended up going with that. And so that's what the chip on the breadboard a second ago was. We'll go back to that. That's the Teensy, and you could use either the Teensy 2 or the Teensy 3 or the Teensy 3.2 or I think any of them post Teensy 2.0 support USB keyboard emulation. So I just used the kind of the oldest model within that range that I had, which happened to be a Teensy 2.0. And I don't really care about having a lot of I/O pins in this case because I can actually, let me throw this for Tuco. So I plan on taking advantage of the fact that I don't need any concurrent key presses. So I'm only going to be using this to switch channels on my video setup. So, oops. So I don't need any of these to function as modifiers. I don't need like chording support. So one really simple way of accomplishing that is just to use an analog input to read the buttons, and then generate a bunch of voltages using a resistor divider. So the simplest incarnation of that is just a long ladder of switches and resistors that function basically like a potentiometer, with the push button acting like the potentiometer wiper closing a circuit at a particular point in the resistor divider. I'm going to try turning off the kitchen light. I think we established that helps the autofocus. Oh, is that helping? Is that any better? I think the frame rate's going to be lower with less light, but might have to switch cameras for this purpose. This thing seems to have trouble with Tuco's radiant moving personality. Did you lose that one? I didn't see where that one went. So let's see. I have a diagram here. Yeah. Switch back to the other camera. So this is the prototype I had, just to see if this was all going to be workable before starting to make something fancy. And let's see, this might be a good place to start actually. So these are just two simple ways to generate a kind of a pad of buttons with, and you couldn't necessarily use this to make an entire keyboard, because the more stages you add to this, the closer together each voltage is that you're trying to distinguish between. So any nonlinearities in the system are going to start to become more of an issue. You might have to have like a calibration table with a bunch of steps. But I think for 12 or 16 buttons, then it should be all right to use just random low precision resistors and just round it to the nearest kind of voltage bucket and assume that we'll figure out which button is pressed effectively that way. So this strategy on the right is a little bit nicer because here I have a voltage divider from ground here up through +5 over here. I drew this kind of in the way that I would prefer to route the tracks on a flexible PCB, and it seemed preferable to put this last +5 pull-up kind of down here on this side so that you don't have like a full strength, full current +5 rail running all the way down your circuit. Because this way, this is effectively a current limit on the 5-volt output coming out of the USB power here, or whatever rail you're using as your reference. So in this case, I was using 5 volts. Hey, Tuco. So this resistor and this string form the ladder of resistances that give us a bunch of different voltage taps. And then this resistor here, which should ideally be a much higher value, like a couple of orders of magnitude, that acts as a pull-down resistor. So this pin is our analog input. I was originally looking at fitting this on a single analog input because the Trinket has just one free analog pin after you do its software USB implementation. Hey Tuco, you really want to play, don't you? Oh, Tuco, where's your bolt, honey? I see one way over there. I think that's what he wanted. So anyway, this strategy is, I think, what I'm going to go with. This one is a little bit simpler, involves a little bit less wiring, but the resolution, this ends up using the resolution of your A to D converter much less efficiently. I don't even know if it's worth recording the details on this strategy since I ended up kind of discarding it, but so, I mean, if we're in a situation where the layout is much more space constrained, the way this works is by creating a voltage divider between this resistor here and between 1 and n of these resistors in a string. So when you press this resistor, or this, so imagine, for example, all these resistors are the same value. If you weren't pressing any of the buttons, this is pulled up to 5 volts. If you press the first button, then you form a divider between this resistor and this resistor, and assuming you're kind of tapping the voltage over here on this common rail, the value you end up getting is half of your power supply voltage, so call that 0.5. But then you move over to the next button and press that. Now the value you're getting is 2/3, and then you move on again and it's 3/4 and then 4/5. And so you actually kind of asymptotically approach the plus rail in this way that is not so efficient. Whereas over here it's actually linear because you have ground over here and then +5 on the other end of this chain of resistors. So anywhere you tap a voltage off of here, you get something which is pretty close to linear. It is nonlinear due to the effect of this pull-down resistor here. So that's why you want to make that kind of as large as you can tolerate to reduce the effects of that nonlinearity. You can also certainly get fancier and have different resistor values here, but it's much easier to build something like this if you can just choose most of the resistors to be the same value. So in this case, I'm going with something, I could see the resistors in this stage being somewhere between like 1K and like 20K probably. And then this resistor just being an order of magnitude or 2, and then this resistor here, the pull down being just an order of magnitude or 2 higher. So let's take a quick look at what this looks like on the oscope, just to make sure the waveform isn't surprising and maybe get a picture of that before we go too much further. Also, Tuco is on the desk. Maybe we can get him on camera. Tuco, what are you doing? You exploring? had my ground attached with a resistor, which works fine, but is a little bit confusing when I'm trying to get something on video, to have a flying resistor. So that's another ground. Carefully attach. Oops. This is a little bit tenuous because I actually don't have this soldered on, because I didn't want to solder headers to this TNC. So I just have it kind of pressed into place with the the torsion of the pins as it's angled, kind of holding the electrical connection in place. So yeah, not especially strong. I just wanted to test this out and make a couple of measurements, but it doesn't have to last super long. Where's my scope thing? Here it is. So I'm just clipping this on to see on the O-scope the same thing the microcontroller is seeing on its A to D converter. That is blue wire, or the side of the resistor. Oh, something like that. Let's see if that's still operational. Oops. Great. Let's see if this is actually working both on the computer and the O-scope, and then get a picture of both. Yeah, this is set to type some very strange things. Anyway, let's look at this on the scope. Okay. So I have this set up to be ground when none of the buttons are pressed. Then we have button 1, 2, 3, 4. So you can see they're pretty much evenly spaced, and if there was a 5th button, then that would be at about the 5-volt rail. So I think that's enough of that. Let's take a look at the computer and the program that's running on here. And then I think that's probably enough poking at this, this prototype. I think it shows that this is a workable thing. I'm not necessarily going to breadboard it with the actual number of buttons and the actual resistor values. So it's possible that I'll still come up with problems related to extending this to 15 buttons. But I don't think that's going to be a problem. That's still, the number of buttons, is like 100th of the resolution of our A to D converter here. And so, it's not really what you're up against. It's a combination of things, but mostly the resistors. So it's possible that maybe this doesn't end up working and I have to kind of calibrate it or use nicer resistors, but it seems like it might work with 15 or so buttons and just plain old kind of 5% resistors that I have handy. So let's take a look at the computer. Oh yeah, these buttons, I'm totally not used to where these all are yet. I think this is what we want. Of So yeah, the keyboard HID API for Teensy is actually quite nice. There's a summary of it on the PGRC website, and I found it also useful to take a look at the source code to see how it actually works. But this ended up reading pretty straightforward, so like, you don't really have to know much about what's going on under the hood to make this code explainable. So I'm not, oh, this is some garbage. So is that what I was typing? Yeah. So right now it's set to press Alt Shift A B C and D, which I guess type weird control characters on macOS. I found it useful to have a way of viewing raw events. So I don't know what the preferred kind of macOS tool for this is. Like if there's a good OS X developer tool that just displays raw input events. I'm sure there's something like at the Cocoa level that I am just not familiar with. But one that I do know about is XEV for X Windows, which you can run under macOS still. So a lot of these are going to be mouse related, but let's just zoom in on this and then press the keyboard keys, and we should see a verification of what we're actually sending from the Teensy. I need to bring this over here so I can have that be focused. Okay. So if I just press regular keys on my regular keyboard, they look pretty much like that. You can see, so if I type QWERTY, you can see there are a couple of places there where the name of the key appears, and it also includes, like so if I press Shift, that's a separate key. So Shift Q doesn't show up as like Q with modifiers, it shows up as press Shift, press Q. And there's so many different ways of representing keys. The one that USB uses internally is actually just every time you send an event or every time you pull the keyboard status, you just get an array with here's all the keyboard modifiers, here's up to n of the keys that are pressed. And that has some advantages because you don't have this problem of, if you lose state on one side or the other, then you can't get keys kind of stuck pressed. So if you send another event and that key is no longer pressed, then you're guaranteed to see that key is no longer pressed. This is the other style, which is maybe a little more useful for applications, but maybe less reliable from the hardware side. Because if you had hardware that spoke this protocol, like a PS2 keyboard, then, for example, if you lost a key up event, then there's no way for the application to notice that that key's been released, except for pressing it again and releasing it again. So that was something that they changed in USB. So if we press these new buttons, we should I think this is A. Yeah, so it immediately presses. Yeah, so that mode switch key is actually Alt. So it presses Shift, presses mode switch, presses A. We should be seeing it do that same sequence for release. Oh yeah, those are release. So it's weird that we're releasing the modifiers before we're releasing the actual key. I think at the USB level, those are going to be happening at the exact same time. So it might depend on the application, like what it's expecting. It's possible that some applications that are really picky need an additional USB event. So we send a USB event with the modifiers and the key we want to press, then a USB event with the key released, and then a USB event with the modifiers released. Probably doesn't matter that much. At least it didn't seem to for OBS on Windows, which is where I tested this. All right, I think that's enough playing with that. Is that enough of this? So I'm just trying to go through stuff that I needed to get on camera from my kind of pre-experiment here with the breadboard. I think that covers it, just the software. I guess we could go through the software a little more since we didn't really go through the software at all. I mean, that can happen at any time, but might as well do that now since it's working. So this is really just based around sampling the analog to digital converter on the teensy and looking for flat spots in the waveform. And so I'm not really worried about sampling it at a super consistent time base, but I'm trying to roughly sample it every 5 milliseconds, which is about twice what I would ever want to send like keyboard events at. And having this be not exceptionally fast gives us a little bit of keyboard debouncing for free because we're looking for a flat spot that's, kind of further apart on the waveform. So we're sampling, and then we're looking for 2 samples that are pretty near the same level. And then only then we're looking at that value and then seeing which of those kind of quantized brackets it's fitting into. So in this Arduino loop, just every time this runs, approximately every 5 milliseconds, it does that comparison between this reading, the current reading and the last reading. And if the absolute value is below this threshold that I just, determined experimentally, it seems like with the amount of noise I'm getting in the system, the value stabilizes to within a couple of least significant digits, which is what you'd expect. So I'm being conservative and saying if it's within 4 counts, call it even. And so only when it's stable, the rest of this code even runs. So when I have one of those stable levels, I try to figure out which of those voltage levels it's fitting into. And so this is all based on assuming that the voltage levels, that their size can be described by taking 1024 counts, which is the total in this analog to digital converter, with the Arduino API set the way its defaults are set to. And so we're taking that 1024 and dividing it up according to the number of resistors there are in our ladder here. So the way that's set up here, that'll be 1 greater than the number of buttons. So we have 4 buttons, but then 4 plus 1 over here, 5 resistors. So that constant up here is reflecting the number of resistors we have in our ladder. And so this is basically the same as if we were to take 1024, which is our total voltage range that we're dividing up, and then divide it by the number of resistors. We want to do that, but I didn't necessarily want to do that division because if I flip this around, I can do it without losing precision. Because the way the rest of this calculation was going to look is, having calculated the size of each of those voltage steps, I want to take this A to D reading and divide it by that value. So actually, I don't have to deal with floating point here if I do the reciprocal here. And so you can see that's pretty much what I did before. I swapped this fraction around, so I'm multiplying by the number of resistors and then dividing by 1024. And then this addition of 512 is the same as if I had added 0.5 before rounding it. But again, I don't have to deal with floating point if I put this in the fraction and add 512 to that value. So that's just how I got that formula. It rounds it to the nearest voltage level without having to use floating point numbers and without losing precision. And I was sure to use a wider type up here for the number of resistors, just so this multiply gives me a 32-bit integer, just in case that's useful. I don't think it actually is with 1024, but in case I guess I have paranoia from cases like that often causing a larger value. So after calculating just which voltage level this fits into, I'll get a number that is just 0 when no buttons are pressed, or 1, 2, 3, 4 for the buttons. And then I just have to check whether it's changed, and then whether it's been pressed, or whether that change involves a press, whether that change involves a release. And I said USB involves just kind of sending the current state of the keyboard, so I don't necessarily need to keep track of changes that much, but I do need to keep track of when there is a change versus when nothing happened, because I need to kind of signal to that USB endpoint that that there's more data available. I need to have a packet there. So there are a couple of different APIs the keyboard object in Teensy supports. This is one of the kind of slightly lower level APIs where you can kind of set up parts of the USB packet and then queue a packet for transmission. So what I want here is if, there are kind of three interesting cases here. There's releasing a button and nothing else happens. There's nothing was pressed and then you pressed a button. And then there's instantaneously you release one button and then press a different button, which probably only happens if there's some kind of glitch, but we want to make sure that the keyboard packet at least ends up in some kind of consistent state if that happens. So it seemed like the easiest way to deal with that was to break this down into a couple of different pieces where we just make some kind of Boolean determinations here based on the value and its previous value. And if the two are different, we know the button, there's some kind of change that we need to send, which involves sending one or two packets. And then whether or not we send the press packet and whether or not we send the release packet are based on whether those values are non-zero. And this keyboard is very simple because we only have to ever have one button pressed at a time. It's a little bit more complicated because we have to fake having some modifiers press and release when these keys are pressed. Under some operating systems, I think Windows keeps track of modifiers separately on each keyboard. So if you were to just always have it keep the modifiers down on Windows, that would work. But on Mac OS, that would end up applying those modifiers to your other keyboards also. So I think this is the most portable strategy. This seems to work fine on Mac and Windows so far, and I would expect it to work on Linux too. And then the modifiers in this case, I'm just keeping them the same all the time since Alt and Shift seem to give me pretty nice hotkeyable weirdo keys that no one else is using. And then there's a lookup table up here in the form of an array in ROM that I can just use, an array in Flash. And so this just starts at value 1. So for 1, 2, 3, and 4, that just maps it to the keys for A, B, C, and D in the USB HID values. So I assume I'll just extend that based on however many keys I want to support. And that's it. It all fits on one page. So I think that's it for bits of footage I wanted about the kind of overall experiment. I think the next place to go for this is actually just to do basically the industrial design. So kind of talk about the size constraints, do some CAD, and then once we kind of have a shape for the thing, that'll go into both a 3D printed, probably 2-piece enclosure made of semi-flexible material, and a design for a flexible circuit board that we can cut on the mill, or chemically etch, depending on which works better. But I have the stuff for milling handy, so that's probably what I'll demo. So I'm going to quickly drink some tea and see if there's anything pressing I need to deal with in the chat or the streaming quality. But then I think I will switch gears into CAD and we can start measuring stuff. Cool, I think things seem to be doing all right. Let's turn off this noisy O-scope. All right. It is totally okay that movie recording has been stopped. Okay, switching to a new audio file, just in case it helps to have that separate. All right. Yes, I need a different mouse and keyboard. So this setup is a little bit weird. I have to switch from my usual demo machine because I'm going to be doing the CAD for this project probably with Rhino because it's what I like and it's what I am most familiar with. It's not necessarily the best thing to demo on videos because it's like an expensive commercial program. But so I think I'm going to do two things in parallel. I'm going to try to learn FreeCAD enough that I can start using it for some demo projects. Maybe do some projects with Autodesk Fusion 360, since that's at least kind of free for hobbyists to use the way they have it licensed. But for this project, since this is just something I kind of need on a more imminent basis, and I think the interesting parts of the video for this project are going to be more in the like flexible circuit assembly kind of stuff than the actual CAD design. I think I'm going to just choose something that's more expedient for the actual CAD on this part of the project. So that said, I have this connected to my other Windows machine, and I have to get my keyboard over here on a big USB extension. Oh, and mouse. Great. Brr. Let's maybe also put away the O-scope. These are kind of funny. This is some detritus from my label maker. It's pretty cool. Yeah. So I have this neat label maker, which might actually be an interesting topic for like a teardown video at some point if I think I can take it apart without significantly breaking it. And I'd been previously using like a fairly normal thermal label printer, and it had problems with the labels not lasting very long in the sun. So I more recently got this awesome label maker, and it apparently uses this tape that actually has a couple of pieces. It's got like a vinyl that the actual label is printed on, but then it has like a ribbon of, I guess, toner, like ink, basically. And so I think the print head is still thermal, but instead of darkening paper, it actually fuses that ink onto the vinyl. And then normally there's like a take-up roller that's supposed to take the ink ribbon and like store it in the cartridge so you never see it, but occasionally the cartridges malfunction and just cause it to like spit these out with every label. So can I get a better view of the cat? Sure. All right. Is this a workable mousing environment? Hard to tell. Let's see if the Apple keyboard was built to withstand an 800-foot USB 3 extension cable. I had this working earlier today. That's like most of what I was doing preparing for the stream today was like yak shaving all the technology I was going to end up needing. But clearly I missed something. Oh, you know what? I think Windows might be extending onto another monitor, so I think I might just have to go over there to mirror it. It is, and I also can't control that with my mouse. Blah. Man, computers, why do we still have them? I mean, I guess this is why a lot of people don't have computers. They just have, like, mobile devices that run walled garden ecosystems. Because those are so much more convenient. Like, I guess that's one of the things that I'm still coming to terms with is how, like, the way that I interact with technology and the way I kind of wish other people did is just so not different, not the same as what most people want. And so it's just totally different goals. Like most people seem to want to interact with technology like technology is something that owes them something. Like oh, I bought this thing. It like owes me something that I was promised. And so it's all about kind of that social contract rather than it being this thing that just has a bunch of components that come together to make something. I saw the light come on my Space Mouse. Oh, here we go. Oh, of course it comes up on the other monitor. You don't think they would learn from how macOS actually like duplicates that on all the monitors? Okay, sorry about that. I thought I had that set up correctly, but I guess somehow it decided that this monitor setup is not the same as it was last time I did the exact same thing. All right, Rhino time. Great. Maybe we can take a quick tour through the... I guess I used Rhino for this project too, which was on my videos, but I didn't really go into the CAD very much. Is this the latest version? Man, version control. When you have like a bunch of files that just have the same name. Anyway. Yeah, so this was the probably unnecessarily complicated thing I made for the Boldport Engineer Superhero music video. So I don't know, I like this program a lot. I think I tried importing this into Fusion 360 because I saw this in my Fusion 360 projects, but I'm pretty sure I made it in here. It's got a place for the circuit board, of course, and then magnets and a coin cell and a piezo transducer that it's using as a pressure sensor. So anyway, let's have a blank slate. So actually, the first thing really, I mean, a blank slate is great, but really also physical objects are a good starting point. So calipers and tactile switches. And flexible filament. So yeah, there are a few options for actually making the switch contact. And you know, I'm sure there are probably going to be some really interesting kind of DIY switches for 3D printers with conductive filament in the near future. But right now it's still by far the easiest thing to just get like a surface mount tactile switch. It's really, you're looking for something that has a reliable contact, so two metal surfaces that have the right kind of plating so they can withstand a lot of contact over and over again. And you're also looking for something that has that physical snap action. Oh, this might need a microscope. So yeah, this is the smaller style tactile switch I've got. Let me show you relative to my fingers. It's rather little. So this one actually is not especially great to press on its own, but it's designed to have kind of a protrusion above it that presses on that little dome, and then the dome buckles down and makes an electrical contact. I really want to show that under the microscope. Let me prop that up correctly so that I can do that. Maybe clean up this setup. Okay, that's nicer. Oh, can I press it with something more photogenic than these dirty tweezers? Maybe I can just clean my tweezers. Cleaning my tweezers? Now, some aspects of this project are kind of clear in my head already, and some are still a little fuzzy. I'm not totally sure how I'm going to attach the two halves of the enclosure. I think ideally I would make it something that I can easily glue together, but I don't know. Maybe there's some way I can have like a snap together seam that the two pieces fit together. But I suspect it'll need glue or heat stakes or something like that. It's easier to unglue stuff than heat stake it. So yeah, here's one option. So if I were to just press this with my big fat finger, I can't really do it because it needs something that's specifically protruding below the level of this flat enclosure. So that places an extra demand on the mechanical design. You know, we can't, for example, have this be like something that was printed directly on the build plate. This has to be something that was presumably pointing up at the time of 3D printing. But other than that, it's nice, and it's pretty small. The other tactile switch I got is this little critter. You know, I don't think I'm recording the microscope. I should at least get a little bit of this. Oh, the computer I record the microscope with also happens to be the computer we're doing the CAD with. It's getting a little meta. Usually I don't have the recording equipment on the stream, except for the camera, I guess. All right, that can handle some multitasking. I get like a flat thing that isn't as big as my finger. How does this look? I guess that gets the point across if I end up needing that for a point. So here's the other one. This one looks really nice. I think this one's probably basically the same construction inside, but then it has this sort of brass plunger on top that acts as a really nice kind of force distributor to the whatever's buckling underneath it. So that's pretty nice. So I can imagine ways of using either of these. Like this one does seem like it would be a little easier to use. Like there are more ways I can imagine incorporating this into a mechanical design that is easy to 3D print in flexible filament. Whereas using a button like this introduces some additional constraints because you've got to have an additional thing that actually pokes in there. And so that's totally doable. It's just additional constraints on something that's already somewhat constrained. So I might actually save these for a different project and use the slightly bigger ones. The one place where these would be nicer is if I wanted this specifically to be pretty thin. But like actually, I think one thing I was debating doing was making a like kind of a side view of what the structures for these two different buttons might end up looking like. Maybe that's actually worth doing on a piece of paper. Oh, too many keyboards. Is that gonna autofocus? No. Right. They're so small. So. Yeah. So this one from the side looks something like has this kind of wide base and then this kind of angled domey bit and then a kind of round plunger in the middle. And then this one, on the other hand, seems to have pretty much just flat square profile with nothing sticking up. And then it kind of has this little well that the disc can press into. So on this side, I can imagine, well, let's say we wanted a button that comes up to, like here. So it's not super thick, but we want to, for example, if the button was really, really thin, you wouldn't have a way to distribute the pressure from a finger up here to this one little point that we want to get it onto. So really what we're looking at is to make a button that's effective out of really squishy, flexible material. We want to have this shaped such that it's like directing the force down into here and not just providing an escape route for the material to kind of squish away from the button. So like if we, I don't even know how to explain this or even like what's worth explaining since I'm certainly no mechanical engineer. But, for example, if you had a very thin piece of material above the button and you just pressed right there, then it would feel like you have this kind of hard little nodule in there, and it would end up kind of deforming that material. Oh, it's really hard to draw when I'm looking at the monitor that has a bit of a delay on it. So yeah, it would kind of end up causing this little sheet up here to deform in the shape of that little bump. So we don't really want that. We want something that's going to kind of hold its shape. Oops. Careful with these little things. So, I can imagine something like a, like a little kind of pyramid-shaped thing. So a smaller version of this would work pretty well for this sort of button. Something where there's sort of a little bump here that is sort of ready to press in here, but it isn't quite doing so yet. Versus over here, that's pretty much what you want, but you also don't want that to just slide off of the little nub there. So I think here what you want is something that has a bit of a little lip there so it can grab onto it, but then it kind of gets out of the way quickly. You don't want it to come all the way down because then it would end up contacting this surface and getting in the way. And then any material kind of way over here may or may not be useful. So I did a couple of different designs for buttons on that, where is it? I think I have it nearby. That kind of squishy pocket operator synth that I mentioned on the last stream. So for this thing, this is sort of a one-piece flexible case that I printed for the synthesizer as an experiment in kind of printing a combination of button and different kinds of enclosure parts, all using the same material. And so I had some test pieces for those buttons. I think this is one of the better versions. So these are designed to go on top of the pocket operator circuit board. And my plan here was that these ridges here would support the structure above the circuit board. And then I had these kind of parallel fins here so that, the idea was that when you press this button, the entire button moves, in this parallel way down onto the tactile switch below it. And I experimented with that, a couple different variations. I think it was tough to make those little support fins weak enough, actually. It's really easy to make them too strong, and then the button's just too stiff. So I printed these with the, this was actually down on the build plate. Let's keep these buttons handy. And then these inner areas were actually printed as bridges with the flexible material. So the texture is pretty weird, but it actually worked out pretty well for what I was trying to do at the time. Didn't end up using that in the final design, but it was something I thought about using. Yeah, there we go. So I think I might try to use some similar ideas from this. So like here, what I was trying to do was, it looks a little bit like a Lego underneath. These interior fins are just trying to help, support, drive the force downward and keep this shape kind of boxy. So, when you press on one side of the button, I want it to distribute that toward the middle, to distribute it to the other side of the button. But I also want the button itself to be fairly decoupled from the area, the kind of like surround between the buttons. So it reminds me a little of designing kind of a big analog circuit without any buffering stages. You don't have anything that's like really rigid. You just have to have gradations of softness and work with that. So I think I still, with these prototypes, overdid it on the rigidness, and making this a little softer would have been nice. But I still like the idea of having the button itself be fairly rigid, and with this flexible filament, it seems to make a nicer object to kind of specifically put in like lines like this that you want to support. I mean, otherwise you're going to get stuff that is very strong, like right where the infill in your 3D printer puts the lines, and so it might bend in unexpected ways. Whereas here I'm kind of reinforcing it in places that are really lined up with the axis of each button. So I think these are all, and all of these are designed for tactile switches with the dome on top, like this style. Looks like I don't have any 3D printed button prototypes that work with this other kind of switch, but I could definitely imagine that working, especially with something like this, if there was just a bump right there. So, this gets a little harder to really flesh out in 2D, but you can imagine taking this in a bunch of different directions, but basically having, some kind of, center support, and then some kind of support going the other direction, and then doing something similar, but with the little bump for that kind of button. So, just to avoid kind of pushing my luck with the flexible filament and all the other design constraints, I'm going to go with this button. So I think the first step with that is just going to be doing a really rough CAD model of this button and then just placing those and seeing what we can make with it. A couple of the constraints we have, so there's the button itself, there's the trinket, or not, sorry, the trinket, the teensy, which doesn't really affect this design too much, but I kind of imagine that this would be on kind of, a tail that leads to the USB cord, and possibly not even like attached super rigidly to the rest of this, so it might have kind of like a flexible strain relief going to the teensy part. And then the circuit design so that I only actually need 3 connections to the teensy, and they're all on this side of the board, so I can actually just bond that to a piece of flexible circuit board that then takes whatever shape we want. So the limitation on the flexible circuit board, assuming I do it with the mill, I can make a square that is up to 5.5 by 4.5. This is the size of my milling machine. The sheets I have of Pyrolux are much bigger than this, so if I need to make one that's much bigger for any reason, I can try doing chemical etching, but I like doing it in the mill because it's less messy and I don't have the chemicals handy. But yeah, I probably won't even necessarily need a lot of this space since this is like way wider than what I actually want, but I can imagine something that's kind of like that size-ish. And then I'm also imagining that to make it more flexible, what I would actually want to do is, since my circuit is really just a line of buttons, I would kind of pack that into a rectangle by zigzagging back and forth. And I can actually also cut, make cuts into the flexible circuit material, so that I think that might help it bend in more than just one axis at a time. Because with this paper, for example, I can bend it like that, I can bend it like that, but if it's bent like that, like it would be around the pole, then all of a sudden it's like really rigid in the other direction, which might not be so good for just kind of stability over time. You kind of want it to be not over-constrained. So having some cuts in there to allow it to flex a little bit more might actually be helpful. So I might also make a square like this in CAD once we get to that point, just so we can start playing with shapes that fit in the milling machine. Is any of this going to be good on the DSLR? I might get a little bit of just caliper footage to use for editing later if I need it, but this is probably going to mostly be something I have the strain on the CAD tool for. So that's way up there, sorry. There's probably a data sheet for these somewhere. I don't actually have the data sheet since I think I just got these on like eBay or Amazon. But these look like a pretty standard kind of tactile switch. This is probably supposed to be 5mm nominal. I mean, the things that actually matter a lot for us are going to be the footprint, which might even just already be in a standard library that we can use. So I'm not going to worry about the footprint just yet, but for this part of the layout, you know, we kind of roughly want the dimensions of the button, but the thing that's actually important is just the kind of dimensions and height of the shaft that we're kind of trying to push on here. So that's just a little under 2mm diameter. It's so metric. And it presses down exactly 0.2mm. Yeah, nice. So yeah, that's gonna look pretty nice in millimeters. I wonder if this one's exactly 1mm thick. Oh no, it's like 0.5mm. I guess I just don't know how much to push the limits, like, you know, how flat is it worth making this? I mean, I think the other constraint here is the magnet we would be able to stick in there, though, assuming I want to make it magnetic, which I kind of do. And I think, you know, assuming the magnets aren't going to be in the exact same spot as any of the switches, so they don't, you know, take up any of the Z height there, the thinness of the overall thing would still then require, you know, like the magnet would be the limiting factor still, even if the switch was as thin as we could make it. What do I have as far as magnets? We want some of that too. I think something like this size would be appropriate. Of different types stuck to each other. There we go. Yeah, because I mean, I don't want a magnet that's so strong that it would rip this thing apart as I try to reposition it, but I want it to be held on pretty snugly. So I don't really want to magnetize my calipers, but let's see what these are. About 6mm diameter. And I think these were like 2mm. Okay, 1.5mm thick. All right. I think that's enough calipers on camera for the moment. Let's go back to the CAD. Okay. All right. Tea is great. Tea is really good stuff. Okay, let's make a button. I'm going to just approximate this button with... It's so tempting to actually make the hexagon shape from the top, but I don't really need that much detail even. So I'm going to just make this a box. What was that, 5mm on this side? assume that's also 5. Yeah, it's like, I mean, it's a little over 5. It's like 5.1. Let's give it a little bit more space, maybe. And the height. And I'm just going to make this the height of the entire body section. So I'm not going to worry about how it actually has that like kind of step on the side. I'm going to simplify this. Just make sure I give it enough clearance. So that's like 1¼ millimeters. Bottom of this button is not especially flat. Yeah, I'll give that 1.3 millimeters just to be on the safe side. Having that be a little oversized is not a bad thing. Alright, that's the body of our button. A rough approximation of it. And then the cylinder. I think we decided this shaft of this was 2 millimeter diameter. Yeah, 2 millimeter diameter shaft. And then I started the cylinder from the z equals 0, so I'm just going to measure that, measure the overall height of the button now, which I think was also 2 millimeters. Yeah. With that 0.2 of travel. Alright. Give that a tiny fillet. No. Alright. So that's kind of our button. A couple of different ways this could go then. I want to figure out how to lay out the buttons and kind of how to shape the overall thing. I also want to do a test print for just like a keycap for one of these buttons to just see how that feels, probably. So probably the first thing to do is just design like a keycap for this button that would fit into like a sheet of some sort, and then do a test print of that while we work on the overall layout. Oh, what shape should these buttons be? I kind of want them to be circular. I kind of think this needs to involve circles. Let's see what we can do here. I guess I also need to figure out how close together I want these, like how, because I mean a big part of this design, I think, is to make it so that I can just stick a thing there and then I don't have to worry about whether it's going to fall asleep or whether it has keyboard focus. And ideally I can get a good muscle memory for where all the buttons are. So ideally I would actually want them to have a unique feel. So you know, so I was thinking about like a matrix of 3 across and 5 vertically, maybe 4. But 5 would allow me to do, I think, everything I need it to do. So I think 3 by 5 is the best layout for me currently. And then so maybe, you know, it would be something that feels like a grid, but it would also have, you know, so like left, right, and middle are pretty easy to distinguish on the horizontal. And then on the vertical, maybe there's a way that I could have textures that are different depending on like what row I'm on. And the textures could either be something on the face of the button or something in between the buttons. So I can imagine like, you know, different like grid lines made of different textures. So like, you know, like a diagonal thing or like a vertical thing or a bumpy thing. So how close do I want them to feel? I also want to be able to, you know, if I want 3 buttons side by side on something that will comfortably wrap around this pole, I think that's probably my biggest constraint. So I've got this thick paper, which is a little thicker than, well, it's thicker than normal paper, but not as thick as the thing that we're building. Hey, train. I'm not really sure where I want to anchor these zip tie things. Okay, yeah, so let's say I want to put it like right there. I've got parts of this pole that have Velcro and then parts that I keep clear for stuff with magnets. And I think they've started to do battle. Like I think the magnets want more space and the Velcro's like, no, don't forget about me. Velcro's important too. But the magnets, you can just put them anywhere. So yeah, I kind of want to just like make some cuts in this paper and experiment with that. Because I think just like kind of holding it around the pole, like this seems like the maximum amount of working width I would end up wanting. So maybe I'll trim that and then see how it feels and then trim it some more. And starting with this size, I'm not going to make it bigger. It's maybe a bit of a coincidence that a couple of the recent streams have involved emulating USB devices, since you know, the reason I'm emulating a USB keyboard here is not necessarily because I like USB, although I am a bit of a USB nerd. This is really just because that's the most, like, the easiest way of accomplishing this job. That's pretty nice. I can get this camera pointed at the pole, so. Hey, cat. So, something like that. And I'm really a little worried about, you know, what the bend radius is actually going to be capable of, but I think there's a couple of things I can do to try to keep it bendy in the axis. So like the switches have, you know, they have one side that's going to be a little longer because the legs stick out, and I could orient that side vertically so that it's more bendy in, you know, in this axis. I could also try to do the 3D printing design to have it be stiffer under the switches and their immediate vicinity, and then less stiff elsewhere. But basically, I think something like this that sticks on to a surface and then has kind of rows of diagonal buttons along it. So I think maybe I want to try recreating this in CAD, and the important things are, well, I mean, I could create this pole if I wanted to, but I think it'd be easier to design something totally flat and then just kind of keep how it curves in mind rather than try to design it curved. So I think I just want to start out with like a rectangle like this in CAD and then like measure this width and cut something that's that width. And I know we still haven't answered the question of how wide the button should be, but we're getting there. This is a detour. I'm going to do some design so that we figure out the constraints, so that we can do some design, so that we can figure out some constraints. I'm going to put this button on a new layer so we can come back to it later. Oops. This is not quite the uncluttered workstation it could be. So that is hidden for later. Let's save this. Okay. So that should be my much larger rectangle that represents the size of my milling machine. Um, $114 millimeters, yeah. And what was this width we ended up cutting? Call it, it's like almost exactly 50 millimeters. All right. 50 millimeters is a nice round width for this. And the reason I cut it at an angle like that was I wanted to give, the opportunity to make it a little taller than if I had just cut it, that way. That may or may not actually be necessary. Like if it ends up fitting on the mill the other way, then so be it, but I wanted to have the opportunity. So let's just put this wherever for now. I think I actually want that to be perpendicular to this line. This is like one of those things that would potentially be easier in a parametric CAD program. Then, oh, is that what I want? I forget how to tell it I want to draw a thing perpendicular to right there. Guess that. Actually wanted the middle there, but that's fine. Okay, that should be 50 millimeters. I'm just going to turn this into a two-dimensional thing that we can use to make cuts. Oh, actually, it's probably easier just to copy this. And now I can just pick the pieces I want. Curve Boolean. Delete all the inputs except what I want. All right. That's a model of the piece of paper. So now I want to try to position buttons on this in an interesting way and then make the rest of the shape around that. So think I want to start by seeing what it looks like if I kind of divide this into threes. I'm so used to dividing things with a midpoint that it's like, oh man, I've got to do work to divide this by 3. But this should still be 50 millimeters, right? So then I should just be able to type that. Starting here, 50 over 3. Okay, so I've got those lines. I've got these reference points for the dividing it into threes. Yeah, I mean, I don't think I'm actually going to use that to place the buttons, but it's kind of interesting to have that as a visual guide. I guess I'm imagining the kind of the ergonomics of like reaching over there, and you want to have a couple of rows of something, but you don't want it to be like an actual grid. You want it to be like arcs, because that's easier to get to like with the wrist. So what I'm actually interested in doing is trying to see if I can place, you know, some arcs along here that then maybe form a grid. I guess if I'm doing this kind of ergonomically, the size of the arc should be kind of roughly like hand-sized. Maybe a little smaller than that. Yeah, I like Rhino a lot. It's my favorite tool for making things when I have no idea what I'm making. You know, it can actually be kind of annoying for some uses. I think I prefer to actually work on the axes right now. Like, you know, there's some things where I would definitely just use SolidWorks or Fusion 360, but like, you know, if I ever think about, you know, oh, if I need like a variable that I can use to change the screw hole size in this design, or, you know, I want to like make something automatically based on the spacing of these parts or something, and, you know, so that kind of stuff, SolidWorks is great, or Fusion 360, but Rhino plus some of its companion tools like Grasshopper are really nice for just kind of like making ideas and trying them out. I was starting to think about this in terms of the axes, so I figured Rhino should come along for the ride. Let's rotate this too. So, kind of thinking like I like that curve so far, but, you know, I want to make sure I still do when there's a bunch of them. So, I think we want 5 of these total. And the X, Y, and Z here are totally arbitrary axes. I can tell it what those axes mean. So here, Oh, is that not true? Maybe I'm getting programs mixed up. Maybe those do actually have to be actual X and actual Y. Okay, maybe I'll do actual Y array. 5 in the Y direction. Can I make something like that work? That's spacing of 24 millimeters-ish. Let's make it exactly 24 maybe. I guess it was negative 24 before, but that's fine. I hadn't actually positioned that vertically where I wanted it yet. I think I might want this to be rotated again. Oh, maybe I actually want that flipped. Yeah, that makes better use of material. I mean, I'm probably going to make these corners more rounded than that, but... So where I'm imagining the buttons here are on these curves, but in the centers of these open areas here. I kinda like that. Let's see how big the button is by comparison. It's pretty little. That'll fit pretty easily. So this gives us an idea of like kind of how big the buttons, like the keycap kind of pieces need to be. All right. I think I just want to split these into pieces now. Explode this curve into smaller curves. And then I've got a bunch of these lines that I can use to divide these circles. Oops. Not the Windows key. Okay, I think that worked. Yeah. Just throw away the pieces I don't want. Don't really need those anymore either. So now I have these other curves, which again probably don't appear in the actual thing, although these I might keep for some kind of aesthetic purpose, because those are kind of nice. But mainly the reason these curves exist is because the midpoint of these should now be where the buttons go. So they could be up to that big, but that's like 12 millimeter diameter, which sounds about right for a button. I think that's a pretty common keycap size for tactile switches. And I don't know how thick I'm going to end up wanting this. Like, this is probably mostly going to be, I guess we decided it was going to be partly the feel of the buttons, but also partly the magnets. And the magnets, I think, were 1.5 millimeters thick. Yeah, about that. So I'm just going to leave these really oversized for now and figure out what to do with that later. Because at the moment I just want to think about the pattern of the buttons more so than really exactly where they are. some any duplicate. I should probably turn off the intersection snaps because I really want the midpoint snaps, and the intersections are usually distraction. So something kind of like that. What do I want to do with these edges? Like what, I mean, could I make that continue the same kind of pattern here? Or make it like kind of a circular, rounded thing? Like what does just a circle look like there? I mean, I think I probably want to do something slightly different, but just for reference, I want to see what this looks like. That's kind of gross. Let's put one of these back together so I can use it. I mean, so I think if you continue the visual pattern, you definitely shouldn't have material like in this area. But then maybe these corners I can just chamfer. Maybe that's the deal. Let's try doing something similar on this side. I think, so I think it might actually be worth getting a model of the teensy in here at this point, because I think this is also going to really depend on, like, I want a good way to attach the USB port to all this. You know, I can imagine having a great button pad that just does exactly what I want, but then it's just super annoying and not durable because of how I attach the teensy. And so I'm imagining something where, you know, so there will be kind of 3 layers sandwiched together. There's a probably milled flexible circuit board layer made from Pyrolux and Kapton. And so that will be then sandwiched in between 2 layers of 3D printed kind of thermoplastic elastomer. So I'll probably use NinjaFlex for that. And that's the same material I made this little flexible case out of. So it's can make a degree of different stiffnesses depending on how reinforced you print it. So, I mean, I think if this spacing is going to be viable, I need to leave room on... Oh, you know, actually, maybe it's fine, because like this rectangle limit that I have for myself, that's just the size of the Pyrolux. I can, like, my 3D printer is much bigger than this. And so, as long as I can get to the edge of the teensy, then I'm fine. Since I designed this so that I only need pins on the kind of far edge. So I don't need the Pyrolux to actually overlap the whole underside of the teensy. I just need it to touch, which is much easier. So I can imagine the teensy going like over here maybe. So that's good. Okay, that means this can actually be trimmed significantly more, and I can make this a little bit wider for the kind of 3D enclosure. I still want a model of the TNT next, I think. Let's see if there's already a file I can grab and import, or if I can just make a really rough model myself. I mean, I could either use a CAD model or a PCB model, but I think somebody might already have. It's a popular enough board that that's the TNC++. That looks like it, except I think this is focusing on details that are not quite what I need. Yeah, maybe I just make my own model that has the things I care about. Since I mostly just want the overall dimensions and the USB port. I mean, that like boxy one that we were just looking at might be fine, but I don't want the pins, and I would want to double check the model anyway. So let's organize this a little bit more. Let's have a layer for the flex circuit. And a layer for the buttons. Okay. Add another new layer for the teensy. And probably the same deal. I'm just going to build this out of boxes because it doesn't need a lot of detail. 30.5. And I think I'm going to kind of round off the height of most of the teensy to the height of the processor. Then the reset button and the USB jack both stick up a little more and seem like things that we want to know about in the CAD model. So, other than the button and the USB jack, that's 2.6 millimeters thick. Oops, I just made it 2.0. Let's fix that. Okay, 2.6. And so the tallest spot over here with the button, that's like 4.25 millimeters. Let's start with a thing over here. Also 2 millimeters. looks like it's supposed to stick up nominally like 1.0 millimeters. I think it might actually be more like 1.1, so let's give it some clearance. Button, and then a rough outline of the USB port on the other side. Whoops, that is not the right height. Had the calipers zeroed to something else. Yeah, 3.8. 3.88. Oh, is that right? I think the other dimension was wrong too. Let's do that over again. It'd be great if these calipers had an indicator when you have the origin set. That looks right. Alright, that's a cute little approximate thing. I don't think I have the Z height on that correctly, actually, because I was just realizing that I measured the height of the connector itself, but the board there is just an approximation. 5.71. Yeah, that is, oops. Okay, so like that's a line that represents a measurement that I just took. And so I can move this down to meet the measurement. And then I'll just Boolean all this stuff together. Okay, there's my teensy. Let's double check that the height of that matches. 5.7 millimeters. Yeah, cool. And I'm not going to worry about the connectors on here since that'll be pretty easy to deal with in the circuit board layout. It'll just be like a 5 or like a 4 position 0.1 inch header as far as the circuit board's concerned. Alright. Teensy. So. Oh, so I mean the obvious thing to do would be to point the cable down, which is probably the right thing to do since that's where the cable is going to be pulling it. So maybe let's just center this. I'm not really going to worry about the Z position just yet. seems like about as far I can push the teensy from the buttons safely. Which seems fine. I mean, I can move this whole thing up a little bit more, but like I also don't want to necessarily make this like super hard to fit on the mill. And I think the mill placement might be a little tricky also, since there are bolt holes in the spoil board that I'm going to have to avoid and or just put other material on top of. But yeah, this seems alright for now. I think this might be enough. Like, we're getting close to having enough information to actually start laying out the circuit board. So we know there's a teensy there. I mentioned having kind of cuts in here for to add flexibility. I might do that post layout, since they can, like, their placement can be kind of flexible. Pun not intended. And so I don't necessarily need to know at this point in the design where those cuts are going. I mostly just need to know where the buttons are, the kind of maximum size the board is going to need to be, and yeah, I think this is fine. So let's trim this a little bit, because I would like a shape that's a better match for what my actual circuit board might look like. So I think I want a line here. Maybe I do want a curve. Maybe that's fine. Yeah, maybe I'll just use that curve to split this off. I don't think this line ended up being important. So those are the 4 kind of tracks for the buttons. And let's try to do something down here. So it'd be nice to have some overlap here. Like, how much overlap? I mean, basically just like the width of the pads. So call it 3 millimeters. Intersection. There we go. Let's move this so that that's actually 3 millimeters. All right, and then that's perpendicular. Great. more trimming, maybe. Oh, I thought those lines were all on that layer. Oops. No, not what I wanted. Oh, I guess that's not entirely closed. That's fine. Let's keep these. Do I still need these for anything? Let's just keep these with the buttons, because they're kind of button related. This is approaching an outline for the flex circuit. Let's see how that fits in the machine. Let's not move that piece. Let's move the rectangle, because everything else is aligned with that piece. Yeah. I mean, that is totally doable. It just involves making a thing that barely fits in the machine. Which seems fine. I mean, this whole section here is not really necessary. But I suspect I'm going to route it going over this way and then down that way. So there might be room for a cut like right in there. And then like down there. Well, that seems plausible so far. So I think ideally, so I wasn't quite sure how to do this part, getting my layout from vector land into circuit land. I know in the past I've done a thing with KiCad where, like, I did the silkscreen art for one of my projects with like a tablet and Inkscape, and then exporting that to a layer in KiCad. So I might be able to do something similar. Although, I mean, the way that worked was to generate a bitmap, which isn't what I want here. So I think what I want here is to get a rough version of this into KiCad and then probably just use it as a guide for placing things manually. Looks like I might need to fuss around with this to see what kinds of import-exports I can do, and then figure out whether there's anything I need to like mark up beforehand in Rhino. Like, for example, I don't know what kind of geometry I'm going to want to have to mark the locations of the buttons. I mean, these could just be points or something. I mean, yeah, I could just do stuff like that. So, let's see. I don't know if I have KiCad on this computer, but it's easy to get. I mean, I could also run KiCad on the Mac, but then we'd be moving files back and forth. KiCad. I mean, we don't even have to use a circuit board CAD to do this. It's certainly tempting to do the traces in Rhino also. I mean, there was a project I experimented with doing that on. It was kind of annoying, but the results were really nice. I was trying to make a bunch of circuit boards that all fit together into like an icosahedron, like a 3D shape. And so I had the traces all laid out as 3D splines in space, like around a sphere, and then projected those shapes onto the plane of each circuit board, and then used those to make cuts to separate the. Like, I did the whole thing really designing the inverse traces instead of the traces themselves, which led to a nice milled result. So I had these nice like sweeping vectors defining the isolations that got milled in the copper. I could definitely do something like that for this. I mean, I was going to say nobody will see it, but I mean, I guess I could make the casing on this translucent, and not a lot of people saw it on the other project either. It was certainly a case of putting lots and lots of effort into something that not very many people were going to end up seeing. Hey, Tuco. Hey, buddy. Meow. So many things to install. I mean, the circuit here is pretty simple. Let's see if I have that other project handy, actually. I mean, a picture is worth quite a few words. Is it in here? Early this year, right? I did this part before. Maybe this was last year. Yeah, I think this is the giant 3D model with everything. Oh, that's the room it was going to be in. Well, my model of it. Actually, that was pretty close to what it ended up looking like. Oh man, there's so many layers. Shipping crate. Oh, a Tuco, that's really sharp, little guy. Oh, let's gotten more stuff. Oh, core. Oh, yeah. I hope this is still coming through despite the video compression. But you can kind of see what's going on. Maybe I can turn off some of this stuff. Oh, or maybe I can just make it more solid. Oh. Maybe slightly less solid. Oh geez, what is it trying to mesh? Man, art projects. So good at having weird geometry. Okay. Turn off the museum. Model is where pretty much everything I want is. Oh, here we go. And fab. Welcome to a tour through my messy art project. There's a piece in here that's actually relevant, though, the circuit board design. Just trying to turn off some of this other stuff. So you can kind of see what the project was, at least, though. This was like a hanging, like this part hung from the ceiling. I don't know what this bounding volume is. Data. Because I use this model for a bunch of different things. I fabricated a bunch of parts using this CAD data, and I think I also used it for some software-related things. Guides. Oh, I guess I had a whole bunch of reference stuff there. There's still something really slow here. I mean, there's a bunch of 3D models in here. There's a Raspberry Pi case and some audio amplifiers and power supplies. And these are like resonating cavities designed for these speakers. I think I can just turn off all of this, though. Core electronics. No. Printed. I think some of my layers might have gotten a little disorganized. Or maybe there are just so many different categories. So there's this whole categorization for parts within this bottom half, and another for this top half. I think I just want to turn off the whole top half. Great. So then in here, yeah. I don't know if I have all the intermediate steps that I used for designing this, but basically a lot of these wires are kind of like air wires would be in a circuit board layout program. So I modeled, I think I turned off some of those parts. I should turn them back on. I modeled some of the electronic bits that went on here. Oh, let's open the core. There we go. Right, okay. And then, oh, there's some 3D printed pieces that are missing here. Those are important. There we go. Can we turn off the snails? I ended up calling these things snails. They're like support pieces that were supposed to be removable. I'm pretty sure there's some way in Rhino to find out what layer the highlighted part is on. But it escapes me at the moment. Oh, that's right. You can find the layer down here, I think. Layer, bottom half, printed T-glaze. Yeah, I really burned myself out building this thing. It was just way too complicated. Okay. Oh, this is still rendering really slow. But okay. Great. So this was a weird infrared reflection sensor made with an FPGA, and so each of these blue boards was a, I keep saying was because I want to put this project in the past, but I still have it. It's still like an object that exists. So these are infrared transmitters. They're just modified from kind of security camera illuminators. You give them 12 volts and they blast out IR. These are like 1 watt LEDs or 3 watt LEDs or something like that. And then these little black devices are infrared receivers, and they're closer to what you'd find in like a like an automatic faucet in a restroom. So my plan here was to have this kind of sphere that sends out flashes of IR, modulated IR light from each of these beacons. And then for each of those flashes, measures the relative response on each of these sensors and uses that to kind of make a 3D map of its surroundings. Like a very primitive eye. So the idea wasn't to be higher resolution or anything than a camera, but the idea was to be kind of like a sensor that would sense its entire surrounding, so it wouldn't just have a single lens or a bunch of lenses. It would have this kind of diffuse field of view all around it. So then this board up here is an FPGA dev board, a really little one, little 3D printed bracket to hold stuff together, and then small wires went out from here into these holes. And then from there, this circuit board just carried everything. So yeah, so these orange areas are not actually traces, they're gaps between traces. I tried to keep those as consistent width so that I can mill these pretty easily using the same tool and have a good consistent look. But it means if you trace these through, like, this is one pin of, so I've got these 2 pins are power. It has a built-in amplifier, so it has a decoupling capacitor and power. And so this is one electrical trace that goes through here, gets soldered to a wire. And then I had bridges across these gaps between boards. So in each of these gaps, the 3D printed piece here holds them mechanically sturdy, but then electrically I just did jumper wires across here. But the traces were continuous still, because as I was laying these out, I laid them out in 3D and then projected them on this surface. And so they tend to be smooth even as they cross between boards. So anyway, this is sort of an example of one thing that I could do if I chose to go down the path of laying out the entire circuit in Rhino. I think for this particular project, I'm not going to go to the trouble of making it so pretty, and I might just try to do something simpler. So let's just try KiCad. I think it might be set up by now. All right. Let's see what kind of import options it gives us. All right. project, cam switch, flex PCB. I keep wanting to zoom this, but the zoom keys are all different in Windows. All right. I think Tuco's hanging out close to the heater for a reason. All right. Empty schematic, empty circuit board. Okay, let's see what we can do to get our mechanical reference points in here. Oh, a DXF file seems like a good option. It's going to go onto the user drawings layer, which seems fine. So maybe what we want is we want the board outline and then like circles for all the buttons, and maybe smaller circles or points to indicate the centers, or maybe little squares to indicate where we want to put the actual switches. All right. So we want to turn this into something flat. Let's get a wireframe version of these shapes. Oops. Okay, so we just extracted a wireframe version of that and then projected a lot of it to the XY plane. I'm just going to hide the stuff that didn't project because it would have been degenerate if it had. Where did that button go? Oh, tack switch is what I wanted. I mean, I think I just want like a 5 by 5 millimeter rectangle at this point. Well, I guess this has some useful lines to reference. Let's make a wireframe version of this too. Okay. Don't think I needed that. That looks useful. So I want that outer circle. Kind of want more than just that though. Okay, that'll be my proxy button for the circuit layout. All right. Not going to worry about this now that I know that fits. Grab this by the center and just copy one onto each of these. Now I've also got these points. I'm not going to worry about points. I don't know if points turn into anything interesting in a DXF file or in KiCad, but I'm more confident that these shapes will be useful. Okay. That looks like what we want our circuit board layout to start with. And then we can build a case around that. So let's see if we can get the import-export here to do anything useful. A lot of export options to try if that didn't work, but let's see if the defaults ended up working out. Oh, okay. Well, that's. I think I forgot that Rhino, when it exports a DXF, it uses the current camera. So I'll need an orthogonal view from the top. But I think other than that, that was probably all right. Ooh, that's a slow block. Is that not real? That looks pretty real. Did I find an unselectable item in KiCad? Oh, I guess that worked. Okay, let's try that slightly again. So, let's do top perspective. I also, I think it includes units, but I just want to make sure that I have a good size reference. So, since I'm probably going to need to do this on like a 0.1 inch grid, I'll make like a 1 inch square. I just wanted to line that up with stuff down there too. Alright, can I export this now? Okay. That looks nicer. Let's see if this, if any of this is the right size. Can I move this to be on a grid? seem like it'll help. I was going to try to move the grid origin, but I don't think I can even do that without a good way of snapping to that corner. I mean, the reason I want these parts is mostly as a like a location reference. It'd be great if I could have stuff snap to them directly, but I mean, even just kind of having this as a guide to draw over would be helpful. But I would like to measure things. Well, how big is this grid? Oh, here's the grid. So, yeah. That looks like the right size. I just counted 10 grid squares across. Yeah. Alright, well, I'm not super fussed about the positions being weird. I guess I can delete this now that I know the sizes are fine. And maybe this will be easier to deal with if I rotate it. That one curve really does not want to select. That is strange. I guess it works if I draw the box the other direction. Okay, I think that's what I want. And I wonder if I can actually use, I wonder if I can change the lines here to be my edge cuts layer. I'm not sure how these, like how the selection model works for these things. Huh. I hope that's old news. Somebody's saying the only way to change a trace's layer is to redraw it. Copying artwork to a different layer? This is recommending changing it in a text editor. Okay, well, I mean, I guess I could have just put it on the right layer when I imported it. I just didn't want to use all of these for edge cuts. Maybe I'll import it again and see if they line up so I have a copy on each layer. I actually still don't know whether this has got separate objects I can manipulate yet, or whether this is just one big monolithic object, though. And maybe I just end up importing another copy of this from Rhino that just has the... Yeah, maybe I'll just do that, because I don't know how to break these apart in KiCad and edit them as separate objects. Oh, type in the right keyboard. DXF. Alright, can I make this line up? Well, okay, these were definitely separate objects because I was not able to move them all in sync before, so that's going to be annoying too. Well, let's at least import it on the right layer and then see if we can move it. That top section does not come with me when I drag the rectangle from the top down, but it does when I drag the rectangle the other way. I have to flip it 3 times. Oh no, I meant to be rotating it, not flipping it. Oh, did that not stay grid aligned? Oh. Okay, let's try a different plan. Can I maybe, so I can't change the layer according to some of that documentation. Is that? It might still be accurate. I might have to get out of text editor. Or try to do 2 imports deterministically, like without moving it. Let's see if I can do that. Let's just delete this. Don't know what it is about that curve. Okay. So that'll obviously need moving, but I don't even know if these have the same origin in the DXF files. But let's see if they line up. Okay, great. User drawings and edge cuts. Great. This chain of errors. It's like I make a mistake and then I press Control Z on the wrong keyboard. And then what have I done? Gotta select it that direction. Right click, rotate. That direction. Alright. Now we have an edge cuts layer that actually lines up. And our little reference square. Okay, so this user drawings layer, we're not going to actually use that for anything in manufacturing, but we can have that as a guide for where the components go. But then the actual edge cuts layer will go to the mill. So this will actually turn into the mechanical outline that we're milling. So I wanted that to actually be as accurate as I could make it easily. Okay. I think the next thing to do is to actually pick out some buttons and start placing them. So let's see if we can find a part in the library that already does what we need. I am going to take a really quick break to refill my tea and use the restroom, but I'm going to leave you with my cat. Hey, little tiger. He's a good little thumb cat. Brr. I might put on my other jacket since the long sleeves aren't really a problem. Oh, happy little cat. Hello, train. That train is very much there. Alright. Oh, we want a component. That's what our options are. Well, I could have a larger, a smaller, or a diagonal schematic symbol. I think we just want a regular one. I mean, it's possible we want something with 4 pins, but I guess none of these actually break out the 2 pins separately, since they are connected to each other. Let's just use this. And I'm just going to worry about one of these so far. Until we get everything right, let's just have one of them. We're also going to need resistors, and I think we want either 0603s or 0805s for this. Had some resistors handy. Yeah, I didn't necessarily have like big packs of resistors that were an amazing value for this, but I think the two closest values I had were like, well, so I have 1.6K in 0603s, got a big reel of those, like, well, 100 of them. 47K in 0805s. I mean, I'm thinking 47K times 16 is going to get a little big, but maybe not too bad. The problem is that doesn't give us a whole lot of difference between that resistance and our pull-up resistor, pull-down resistor, or whatever we end up using. So maybe the 1K are a little nicer. That'll end up creating a total resistance of around, well, this is like 1.5K, so yeah, that'll be fine. How many total buttons are we gonna have? I think we're doing 3x5 still. Oh, I just want a thing that I can use to do simple math. Maybe I'll pop calc. So we have the 15 buttons and 16 total resistors, and these are 1.6K ohms. That seems like a pretty reasonable resistance for the whole thing. So then the lowest resistance of any of the taps would end up being like 1.6K, and then the highest resistance is going to be like half this. And then that'll be up against our pull-down resistor, which could be like, I'm sure I have some like 100K or something. So I guess if we're going with something like this, I'm looking for maybe, I mean, 603s seem like a good size for this. So we got 603 1.6Ks and a 603 like 100 something K. Not all organized. I still don't have a great selection of surface mount resistors. Like I don't have like an assortment of them. I just have bits and pieces that I've gotten for previous projects. Which is probably fine. Like, it makes more sense to have like the values I'm actually going to use probably. Well, here's 47K, which seems a little low. They're also like I might be worth looking at the looking to see if it's possible on the TNT to turn on the pull up on the analog pins while you're using it, because then maybe I could do pull up instead of pull down. I mean, there are some alternatives to having a pull up or pull down resistor here. Like, you can basically just sort of pulse the output either high or low to treat it like a capacitor that you're charging or discharging. That train sure is being a train. I mean, dynamic logic is pretty interesting. Well, let's see how bad this will be if we use the 47K. I mean, that kind of messes up the linearity enough that I think the program wouldn't be quite so simple. What did I use for the breadboard? I mean, for the breadboard, I was using... the breadboard actually was not that great, and it was still close enough for the rounded code to work. It was a ladder of 10K resistors, and then my pull-up, or my pull-down was 100K. But that was only with 5 buttons. It's going to be a little different with 16 buttons. Anyway, I think I want a larger resistor value than 47K, but that might be the best I have, so we'll stick with that until I have something better. And that one happens to be an 0805. Well, let's see what I'm inclined to optimize this design to make the common resistors easy to solder, but like, I for sure don't want to make the pads so big that we had the problem that the Rasp Dancers passives had, where they were just kind of like sitting in between the two pads. So, resistor. Let's pick some packages for these. Buttons. Oh, there it goes. It's taking a while to load. So it's going to be something like one of these. Probably need to figure out which of these is actually the right size. So we're in millimeters. This looks a little bigger than 5 millimeters. Those look familiar. Yeah, that looks like it might be just the right size. I mean, we should check it, of course, but... looks promising. So what I'm looking at is the coordinates. I have the grid set such that it's snapping at 2.54 millimeters. And so this is tracing out a 5 millimeter by 5 millimeter square, which is about the exterior dimensions we measured. Really, the key here is to measure the distance between the pads, and we'll see if that actually matches. I think that might be easier after I place it. take a footprint for this while we're in here. Actually, I just want to see this on the board. Tuco, what do you want? Oh, I guess it won't let me import this until after I assign. Oh, no, never mind. Okay. I think I just want to do the netlist thing. And then go over here and import the netlist. Okay. Do we have a button? We have button. Great. Maybe this was easier to check in the actual component editor. Okay. Minus 3.1 millimeters. Okay. So I'm just going to check this with the calipers to see if those make decent spacings for the pins. So the X center should be 6.2 millimeters apart. That looks right. And the Y centers should be, what was that? 36 or 3.7 millimeters apart or something like that. Yeah. Okay, I think that's the right footprint. Great. So let's put some more parts down. Probably just gonna have to position these without the grid, which is fine. Huh. Neat. I mean, that's as good as I'm going to end up placing them hand soldering wise, so. Yeah, so basically that for all of these, and then traces between them and some resistors. So, and on here I think I'm just going to have a connector that matches the Teensy's layout. Oh. I've got one of these cards that came with the Teensy. The oldish Teensy's. It's strange that they're talking about for access to the advanced features, C language may be a better choice, but Arduino kind of is C, right? It's funny, like the Arduino libraries, or I guess wiring, it's kind of found its way creeping into some of my like non-Arduino projects, just because then I can use Arduino compatible code. So these, yeah, I think I just lined this up with these bottom five. So I don't need pin 23. I'm using 5 volts and ground as the two ends of my potentiometer. And then this is the analog input I'm using up here, pin 22/A11. So I think I'm just going to draw that as a 5-position 0.1-inch header, like probably a surface mount header, and then just solder it to that. Kind of butt the power lux right up against the holes and solder it face to face. All right. Let's pick a resistor footprint. Yeah, that's kind of nice. That's an 0603 with longer pads for hand soldering, which seems applicable here. I don't ever want that visible. I don't know why that's on by default. And I'm going to make this 1.6K because that's what I have handy. And yeah. Yeah, I think I pretty much just want those. I might want to manually number these even, because I want them, well, I don't know. I don't really care about the switch designators matching. Let's just wire this up. But that's not what I wanted either. Well, let's make some little sub-blocks and then wire them together. guess I should be arranging this. I'm used to arranging things in kind of ways that make sense in powers of 2, but this is about multiples of 3 and not powers of 2. I hear you, little guy. Hey, cat. Chico, I don't know what your intention is. You sure are doing something. Oops. That's not the wire tool. All right. Should have 9 little switches now. Two more groups of 3. This is when I maybe should have the paper in portrait. Because I totally could break that up. It'd just be nice not to have to. I mean, I could have the schematic zigzag like I'm planning on doing the real circuit, but that seems like more effort than it's worth at this point. I think I just want the schematic to be pretty straightforward, and then I'm going to lay it out to match the physical shape I need. I don't think that actually connected. I feel like in pretty much every schematic editor, there's like I have to be very paranoid about whether things are actually connected or whether they just look like they're connected. It'd be cool if there was kind of a more definitive way of being sure in the UI design. Alright, I'm going to count these buttons. I think this is the right number. Group of 3. 15 buttons. All right, and that, so this top wire wants to come back. I guess it can come back this direction if it wants. Oh yeah, so I think originally in my diagram I had, man, my mouse is falling apart. I think originally in that diagram I had the wire going around the other way because that's how the trinkets connector was done. But I think now that I'm using the teensy, it should, like I should take a look at that connector and see how it's done. 5 by this maybe. Oh, I somehow tossed away the little piece of paper that had the teensy pin out on it, but that's fine. Hey Tuco, what do you want? I hear you, little guy. Oh, that is the wrong teensy button. There we go. So I think I want pin 1 to be on this side. Does that match? Oh, Tuco, hey buddy. Oh, and there's my pin out. He must want to play. Hey Tuco. What's up? Meow. Where is the bolt, little guy? Tuco. I don't see the kind you like. I can throw this one. I don't think you like this kind though. Yeah, see, that was disappointing. You know, I think Tuco just can't find any bolts. Tuco. There are a lot of them in here. Yeah, he's really into those things. Okay. All right. Yeah, so I had made pin 23 on here, pin 1, pin 5, or the 5 volts, pin 2, etc. I'm just going to replicate that. Need to go. Okay. I hear you, Tuco. Oh, cat. Alright, so that should fit. And then this is reset. This is an I/O we're not using. This is an I/O that's important. That's our analog input. also not going to worry about kind of having this trace snake around. That made sense in some of my earlier sketches, but right now I just want this to look like a pretty classic voltage divider, because that's what it is. Alright, and then some power. Oops. I think it just needs that pull down or pull whatever resistor I end up having. I think the closest thing I have is going to be that 47K, so let's just put that in here for now. Oh, Tuco's rubbing up against my leg. I think it was also in a different package, like 0805. Yeah. Alright. I hear you, Tuco. Hey, little guy. Where's the ball? Okay, that seems fine so far. We have a big ol' resistor divider with a bunch of taps and a bunch of switches, and 3 simple signals going back to our teensy, and we can mess with these resistor values if we need to. So let's see if that looks alright after we get it into the circuit board. Oh, how much do I care about these switches having crazy numbers? I don't think I care that much. I'm just going to lay them out based on the rat's nest list, I think. Alright. I have the traditional stack of components. Yeah. I feel like there should be some kind of ceremony involved in this, like breaking a piñata or something. Oops, don't want to move the labels separately from what they're describing. Okay. I just want to line up all these resistors. I keep thinking that right click while I'm dragging it rotates, but I think that's an eagle thing. R while I'm dragging rotates. That's also the pull down resistor, so that's not really relevant yet. Yeah, I think I just want to sort all these switches and resistors and things. I know, is this the first one? I don't even think that's the first one. Oh, I didn't pick a connector for the teensy. Let's actually get something in there. Really just looking for something with 0.1 inch spacing, preferably surface mount. Ooh, those look nice. I mean, this would be easy to make something for. I just thought there would be an easy set of non-through hole headers I could use for this. I just don't see surface mount. Oh, these are surface mount. They're 1.5 millimeter. Okay, let's just start with a plain old header and change the pads. Actually, our plain old, oh, pin headers. Oh, surface mount? Something like that, I don't know. Alright, let's see if we can just make a derivative of that footprint. This is another one of those things where I forget whether it's easier to do it in the schematic or in the footprint. great if there was, like, I feel like these header type things, like, it's not so much that I want a lot, like a big library of them, so much as it would be nice to just have like a really easy way of parametrically generating what I actually want. Uh, And then it's just like little library management stuff, like, you know, do I have a new library just for this? Do I have some general purpose library I stick this in? It's like I kind of don't want to manage a library just for something that's like obviously a one-off. So in the past with KiCad, one thing I've done is to just like there's like a cache file that the PCB editor creates with local footprints, and I've just edited them right in there, which is probably bad etiquette, but it seemed to make the most sense at the time. So let's see if we actually have that. Yeah, that's flexpcb cache.lib. Maybe I can just open that and make something right in there. Footprint editor. I don't know why I can't just open the library file here. Load footprint from current board, is that what I want? Maybe it just makes the actual library invisible at this point. Like, I mean, I could just edit this, it's just I want to give it a different name. And so what I would want to do is I want to save a new footprint in the cache library for this board. And that won't show the connector because it doesn't exist on the board yet. Can I give it a name on the schematic for a footprint that doesn't exist yet and then create it? Well, let's try using that as a starting point. Just go through the net list. Close this. Import it. Do we have a connector? I mean, this one is what I want, except I'd rather not have the holes. Like, I'd rather this board be entirely surface mount. Can I just edit them directly here? There's probably a reason not to do this, but I haven't found it yet. want to make these rectangular too. This would need more work if we were actually going to send this footprint to the fab, I think, but for this, I'm fine with it. I think that should be connected though. Why are we not getting... I don't see my air wires. Where are my air wires? Oh, I guess they just needed to be poked. Alright. That looks right. I might want the grid just so I can line this up a little bit. Oh, now I can't see the grid. Oh, this portion of the board is pretty close to being on the grid. It's not quite on the grid, but... I mean, it doesn't have to match exactly. Again, it just has to be as close as the soldering needs to be. Yeah, I don't know how to get that perfectly lined up. I think I'm just going to turn the grid off and eyeball it. Alright. So make sure that is oriented correctly, because there are a lot of ways that that could be oriented incorrectly. Actually, I think that is upside down. So we want the trinket to hang off to the left. Yeah, that just needs a 180. Cool if I had a center line for this. I mean, these should be on the center line, but that's ridiculous. Alright, that'll be fine. So, instead of playing the jigsaw puzzle, it might actually just be easier to follow the order that this is laid out in, even though it's kind of weird. So, switch 1. I'm just going to do this roughly first and then do a real layout. Switch 15. these get linear, I think these just start to go in order. Alright, and now kind of the same idea with the resistors. Oh. Yeah, that seems nice. This definitely feels like one of those projects where if there were just really nice scriptable EDA tools, like I could be writing a script to make pretty much this entire thing. You know, maybe not the routing, maybe I'd use some of that by hand, but like at least positioning a bunch of things according to input files from CAD, that'd be nice to automate. Alright. Oh, let's get the cat back on the camera. Hey, little guy. Much better with KiCad. Alright, such cat. So I want this current limiting resistor kind of close to there, but I want to keep a little bit of a margin. Similarly with this. And then I think everything else just gets arranged as consistently as I feel like it. Hey boy. As soon as I point the KiCad, he wants to go do something else. Wow. I hear you, boy. You want a more bolt? I'm still kind of stiff bending over and picking up his bolts from falling on my spine the other day. So far, by far, the most dangerous object in the shop are my socks. I just slip on stuff and then land. And the landing hurts. The slipping is mostly just kind of bewildering. Like, why can't I regain traction? I hear you, boy. Where's the bolt? I don't see the bolt, little guy. Yeah, and this is going to be a pretty intense milling job. I mean, it won't be that bad. It's just like a lot to get right because I'm just milling like the entire bed full of Pyrolux. So I'm going to try to design this so that I can mill it using just one tool, like just the 64th inch, I think. I wasn't really paying that much attention to the orientation of the buttons, but I guess I did put them, I was talking about orienting them earlier to improve flexibility in the axis that's horizontal now, so we can kind of curl it around stuff. And I think this orientation is probably the best for that purpose. Hey Tuco, what do you think about surface mount parts? Okay. That seems to be a workable layout. Let me turn off that user drawings layer now. And I think now just choose a pretty thick trace and route this. I want to tell the design rules that I'm using wide traces. I always forget like what this is in how big my tool is in these units. 0.39 millimeters. I think the widest my tracks can be is roughly the width of the 0603 resistor pad. So, how big is that? 0.9 millimeters. Those are nice and thick. Hey, Tuco. Oh, little cat. Where's your toy? Oh, here it is. It's behind the surface mount parts. Lucky kick. Oh man, Tuco and I get into this schedule where he really wants to play and I'm really into a project. Let's see, so I'm snaking around that direction. What's up, Tuco? Where's the bolt, little guy? Oh, I don't know if I'm gonna have to go around the back for that. I'm trying to figure out where this long trace wants to go. I think it wants to go on this side. I mean, these switches, I can also use them as jumpers quite a lot if I need to. I may or may not end up needing that, but each switch has 4 terminals, and it has 2 that are bridged, and then 2 that are bridged, and then when you press the switch, it connects them all. Yeah, I think if I want to get all the commons connected, I will need to use these as jumpers. Alright, so let's do the easy ones, and then, well, I'm talking as if I know what order I'm going to do these in. I mostly just pick the ones that look doable, and then just keep repeating that process until I'm done. I'll Also, always just forgetting where the commands are when I switch between different CAD programs. I think I'm going to do kind of a rough layout here and then probably rely on the push and shove router to make it a little nicer. Oh, and running this... That thing I was talking about with making cuts to improve flexibility can't happen if I run this trace like that, so I think I should also rip that one up for now. Let's try to add the traces that follow the zigzag, maybe. I'm gonna figure out how to connect the commons. Oh, I should have my design rules set so that my clearance is a little bit bigger than the 64th inch tool. So 0.4 maybe. Let's see if I can get away with that. That's still plenty of room. Alright. So we'll shove that around in a bit. I hear you, Tuco. Hey, Tuco. I feel like I'm going to end up learning some patterns that emerge from this. Hey boy, where's your bolt? Where is it, little guy? Oh, where is it? Oh, Tuco. Anyway. Tuco, I love you, but you're gonna need to help me out with that finding the bolt stuff. Yeah, I mean, this kind of pattern seems pretty easy. I want to make sure I leave room for that +5 wire. Also unsure whether the design rule check is going to want to make me connect these these two pads to each other. right here I'm using it as a jumper specifically. And I think right there I might need to use it as a jumper also. Maybe I'll just try running that first. I'm also thinking that maybe I can use, like if I want those cuts to be present, I can maybe use traces to make room for them, but I could also probably just squish things together with the shove tool after I get it fully routed. Oh, you know, I should switch to the OpenGL canvas actually. I keep forgetting to do that. Just start using shove right away. Yeah, I think the design rules are going to complain about these not both being connected, but I kind of want to use them as jumpers. Might as well connect to the ones that are easy. places at least where that's going to be necessary. I'm just trying to delete this track now. Okay, so that's, I can kind of push those further in to make room for cuts on this side, and then do something similar manually on the other side. I think the remaining unconnecteds are going to be for, for stuff that's actually going to be connected by the switches. Ah, here's one. One, two, three, four, five. Seven, okay. 7 jumpers and 7 unconnected traces, and 1 cat that really wants to play. Hey, Tuco. Meow. What's up, cat? Such a cat. Alright. I think this is done routing. I just need to remember the key combination for actually doing the shoving without a new trace. Maybe this is just going to happen when I move a trace. Tuco. We have some YouTube inception. Oh, I just want the key for dragging. Oh, Tuco, what do you want? I thought there was something, like, I know I've used this before. Like, I thought it was something where there's some bizarre key combination you pressed or bizarre modifiers that you used while manipulating a track, and then you can use it. Oh, Tuco. Tuco. Oops. Hey, little guy. What do you want? Yeah? You know what this is, Tuco? Oh, it's cold over here. Oh, Tuco's so happy bringing it back. Oh, man. I'm getting anxious to wrap this thing up. I don't think we're going to get to the point of actually running the mill tonight. Since I think I'm going to do the really fiddly stuff that's likely to result in breakages unless I'm paying attention when I'm a little bit less tired. I do want to actually finalize the PCB layout though, which we're really close to. And I think Tuco could use some quality one-on-one time with me. Okay. What's wrong with that one? Oh, I don't even know. Don't know what was wrong with that bolt. So, I just need to figure out how to shove this track a little bit. Well, not just this track, but tracks in general. Oh, is that it? No, that just moved the track segment. Oh, I guess that's what I want. Mouse drag behavior, interactive drag. Can I think I still have to use a modifier. Is that, not that, whoa, not that. Oh, let's just go. What do you want, little guy? Oh, rambunctious tiger. I mean, this isn't looking terrible. I just want to clean it up a little. I feel like push and shove route is totally, like, I want this just without the drawing a new track. Okay, I have to use the restroom, and maybe I'll throw a bolt for Tico on my way over there. Hey, Duke. Oh, so close. What? Okay, I just control clicked the track, and then I dragged it. Yay. Let's make sure that's actually set right. I think we could stand to have slightly more clearance. Just let's try 0.5. That doesn't look right. Well, maybe it is. So that grid is one. It's getting hard to think with all these different things going on, like the cat and the coldness. Tuco. All right, Tuco. I'm going to try setting the spacing to something really large just to see if that has the effect I expect. Yeah, I don't think that's working. supposed to be just calculated from that net class table. Yeah. Like, that's the value. It should be in millimeters. So even if I make this something huge, like 2 millimeters, then, oops. Like that's not 2 millimeters. Oh, Tuco, do you know what's wrong with my clearance? I mean, we only have one net class. Everything should be using this clearance. Like, what happens if I run a design rule check? Whoops. Yeah, there's problems all over the place. But does push and shove see that differently now? No? So I guess it's getting that spacing from somewhere else. I think I've been here before. Hey, Tuco. Hey, little guy. Huh. I mean, that shouldn't be... Yeah, so I mean, the trace itself has a width, because, but it, like the clearance seems to just come from the net class. And I can set it to a big value and it doesn't seem to care. I mean, maybe this is something not getting updated correctly. Let me try setting it to something really big and then like saving this and reloading PCB new just to see if that is an issue. Okay. I guess I just had to reinitialize something. So let me set this to something less extreme. I guess the router only picks that up when it starts or something. So let's set that back to, so it needs to be at least like 0.4 for the tool I'm using, but just to have a little bit extra, I'm going to use 0.5. Okay, I'll save that and then exit again. Back to the router. I want to kind of insert an additional kink into this trace, I think. Okay, now control dragging on the track does what I want. Kind of nice if I could just programmatically inflate a balloon in all the extra space on this board, kind of take up all that room somehow. I mean, that's kind of what I'm trying to do with making room for the wiggly cuts here. Some of this might look a little less crazy if I actually had a grid turned on. Just gonna see if I can unkink this very slightly. Seems fine. So I can cut through along these areas with scissors just to help it be more flexible. And then I have this kind of weird buttony looking potentiometer thing that I can attach directly to a Teensy. Man, Tuco really wants to play. Okay. All right, well, I think that pretty much reaches a wrap-up point for this stream. So we've got a schematic for what it's worth. Very simple little resistor ladder thing with buttons. And got some code to start with. And we have a circuit board, well, a flexible circuit board that we can mill. And kind of the very beginnings of an enclosure based on all that. So this will be the circuit board that we can then start building the rest of the stuff around. Cute little wiggly circuit board. Hey Tuco, is that a hard one? Oh, focus. All right, thanks everybody for joining me and sticking around so late. Definitely let me know what you liked and what you didn't like, and I'll try to keep the streams coming pretty regularly. I might even pick this up as early as tomorrow and try to get streaming a little earlier in the day, since I know these like late night streams for me are kind of weird for most time zones. All right, I think that's it for today. Happy hacking, everyone.